Hello everyone, welcome back to another C++ video. Today we're going to be going over couple topics. Today we're going to be going over basically searching and sorting algorithm basics. And of course we're going to be using arrays and functions. And so I've got my main function here set up already, so let's just go ahead and get started with it. We are going to go ahead and start with the linear search. So first off, a few things, general things about the linear search. Linear search is a search that where we search through an array or a vector. So basically some linear or contiguous piece of data. And starting from the first element, we take that element and compare that to a special value, and that value is something we give, something we're looking for, what we're searching for. Um, that's that special value, right? That's the number we want to search for, basically. And so we basically compare that, see, right? Does the first element have that value? If the first element does have that value, well, then we have found our special value. If not, otherwise, it's going to continue to step through all the rest of the elements and compare the rest of those until we basically find that special value. So when we're comparing, if a comparison is found, we want to basically return what we found, right? Our searching is over, we have found our special number, we want to stop looping and stop comparing. But when no comparison is found, we're gonna have to search through the whole array and then return false, right? We check the whole array, we have not found it, and then return false, saying, okay, there's the number, there's no number, or that special number is not in this array or whatever. We did not find it through our search. So here's just a short little process. I just have a thing here, an array here called num. And I was 1, 2, 3, 5, 7, 9, 10. Alright, so let's say if we want to search through 5, right, we have to go through each of them, right? So you have to check, okay, well, is that first element, is that one 5, right? So is 1 equal to 5? No. Is next element, is 2 equal to 5? No. Next element, 3 equal to 5? No. Next element, is 5 equal to 5? Oh, it is. Okay, cool. So it looks like we found our kind of number there, and it's that fourth number, right? So we have 1, 2, 3, fourth number. That's our guy. Or you can think of it as 0, 1, 2, and 3, that third kind of element or subscript. And let's say if we try to search for 4, well, we'd go through this thing, not 4, not 4, not 4, not 4, and we basically would never find it. So this would return false because 4 is not in our list. So searching is just kind of comparison, kind of finding a one number, right? That's just a general thing, right? And you just do this through the process through all of the elements in the array or vector. And so for some more information, the average number of comparisons for a linear search is about n divided by 2. So basically n being our max number of elements. So here if we have 6 elements, well, our time it's going to take is going to be 6 divided by 2. So it'll take about at least 3 comparisons for us to possibly find the number. And remember, this is the average, right? This is the average over other random data and everything. So some pros to it is the linear search is quite a simple algorithm. It's not too hard to understand. It's not too complicated. All it does is basically search through an array or vector, sequentially in order, starting from first element through to the last element. Right. This thing would be pretty great to just put together really quick for smaller data. It's simple and it would work well for smaller data, but the con is it can possibly take a very long time with large quantities of data, right? So if we have like 20 or 30,000 numbers, well, we could potentially be going through 10, 20, 30,000 numbers to find some sort of value or to find some piece of data, right? That'll take up quite a bit. And if our number isn't in there, well, we will end up going through the entire data set because we'll never find the value, and that's kind of a big X. So n divided by 2 is only going to be only true if the value is inside the data set we have, right? If it's not, well, that might kind of mess up our average, but our average is only if it's true. Alright, let's move on to some code. Alright, jumping into some code I have here. I have my function prototype up here. So I've got a linear search array, and we're going to have it take a constant unsigned int array, and then another 2 constants. So we got 2 constants there. And in our main function here, we've got our unsigned integer here of called numbers that has these random numbers, and then basically we have this function here. One thing I did forget to just do is, well, we basically also want to call this function. Alright, so I forgot to put my function in here. That function call. So now we've also got a function call in here. We're going to pass in the numbers, and here we have our little function. So let me just close that out. Alright, so we've got linear search array, right? It takes this array called, and I named it looked inside me, so that's our array inside here. We've got a size inside here and a value to find. So let's go ahead and kind of get into this function and see what it does. And I have two parts here. One is using a while loop, and one kind of mimics it using a for loop. I'm going to go over the while loop, but you know, this for loop is here for you to look at for practice, or for something for you to try yourself. So let's go ahead and get into debugging this, see how this guy works. So I have this array here called numbers, so I don't have to look at it in here yet. So let's go ahead and get into it. So I've got a couple variables here. We just got an index starting at 0. We've got a position. This is the position. We're going to turn basically the position in the array. What kind of number slot is our value at? We're going to return -1 if the number is not in the array at all. And then we have this kind of bool here that can be used as a flag to set if we found it or not. Kind of think of it as a switch or something like that. Like a light switch, I guess. But okay, to get into this loop, we have a while loop here, and we have our index being compared to our size. So we want to loop while our index is less than our size. So we have our size being 6 here, and our index starts at 0. And we also have this other check, so both of these guys have to be true, and also while we don't find it, right? So as soon as we find it, this guy is gonna well, basically become true, and then this become false, so we'll end our loop. So as long as we have not found it, we will continue looping. So jumping into the loop now, we're basically comparing if our array here at index 1 or index 0, right, our first element, which happens to be 3, is at our value we're looking for, which is 2. Our value is 2 we're looking for, so we did not find that. So let's go through. We're going to increase index and go into the index of the array. Alright, is 4 equal to 2? Nope. Yet again, we're just going to increment into the next index in the array. Alright, now we have a value of 2 in the array is 2 equal to 2. Yep, we have found our number. So we found our number, we're going to set that to true. And then now we're going to set our position to our index plus 1, just so it's easier to kind of read. And then we're going to go ahead and now we're done. We're going to break out of that loop, and we got position is 3. So if we see our position is 3, if we go here, we have 1, 2, 3, and our third number is our number 2. So basically that third position, or again, we can think of it as 0, 1, or 2 elements, right? So starting at 0. And this is essentially a linear search, just kind of going through the array and comparing it to a certain value we're looking for. You can do a very similar thing with the for loop here. You can take a second to pause and kind of go through that yourself. But we do that with a for loop as well. But that is basically the linear search. Let's move on to the binary search. Okay, well, moving on with the binary search. We've got a binary search, and what this guy's going to do is search through a sorted, either an ascending order or descending order, but it has to be sorted in that way or the other, of an array or a vector. And what we're going to do with that sorted array or vector is start in the middle element and then do a comparison to see if the specific value is either we either found it or it's greater than or less than. So if the middle number is the number, congrats, we happen to find our number on the first try, right? And we're going to return that middle position, right? We're looking in the middle, we happen to find it. Otherwise, if not, if the middle number is greater than the number we're looking for, we want to basically reset our searching bounds. This is kind of how our binary search works. So if we're originally starting from our first element to a last element in the array, well, once we hit the middle and we can make a comparison, well, we can change it. If it's greater than, we can change it from first element to middle element. So a little example here. If we're looking at the number 23 here, and our data is an array from 0 to 100, so we have 100 numbers going 0, 1, 2, 3, blah, 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 99, 100. Right, they're all in order. So if we look in the middle here, we've got 50. is 23 greater than or less than 250? Well, 23 is less than 50, so our middle number is greater than our number, right? So 50 is greater than 23. So what we want to do now is kind of split our bounds in half. Alright, we know it's going to be less than 50, so we don't want to search for over 50, so we're going to take 50 as our new bounds. So we're going to remove 100, and we're going to start from the first element of 0 again to our middle number, right? We know 50 isn't the number, so we're going to go minus 1. So 0 to 49, that's going to be become our new bounds. And then we're going to do the same thing. We're going to compare. Okay, well, we're going to take half of that, which is about 25, right? So is 23 basically, less than or equal, less than or greater than 25, and well, it's less than again. So we're gonna go ahead and do the same thing. So split this guy in half. We already know it's not 25, so our next bound is gonna be 0 to 24, and then search through there, and etc. Right? That's how the greater than works. And quite the opposite, if we have the middle number is less than our specific number, well, we want to reset our bounds again, but this time from the first element to last element to, well, now starting at the middle element to the last element, right? So if we have 83, well, is 83 greater than or equal to 50? Well, at this time, 83 is bigger, right? So our middle number is less than, I don't know, it's not that weird. Our middle number is less than our value we want to find. So we've got starting at 0 to 100 again. Well, we know 83 is greater than our 50. So we're going to change our bounds from 50. We're going to add 1 this time, right? So our new bounds will be from 51 to 100. So now we're going to split that in half. That would be what, about 75-ish, right? So is 83 greater than 75? It is again, right? So 75, our middle number, is smaller than 83, so we're going to change our bounds again. So we've got now 75 is not the number, plus 1, so we've got 76 to 100. There's going to be another search for this 83, right? And that's kind of how that works. So to kind of tell or get a concrete number of the maximum number of searches for this binary search, well, we can kind of just do this little thing here. So for ours, if we have 100 numbers, to basically find that, we have to use a power of 2 and then find whatever is bigger than 100. So we have 2 to the 7th power is 128. 128 is bigger than 100. So it looks like 2 to the power of 7, we might, our number here 7 is about the max number of searches. So we'll have about a max 7 searches. And so that is one of the pros, right? This is much more efficient than a linear search, only about 7 searches for 100 numbers. It's not too complicated, it should still be a bit simple, but it's quite a clever algorithm. And might get you thinking a bit. Might not have it right away. But yep, back to this thing. So we have a power of 2, so 2 to the power of n basically equals our max number of elements, right? So if our max number of elements is about, let's say we have 1,000, well, we basically have to find a number n where 2 to the power of n is greater than our 1,000 elements, right? So n equals the max number of comparisons. And cons, well, our binary search has a requirement. It needs to be in a sorted order. It has to be ascending order, either lowest to greatest, or smallest to greatest, or descending order from greatest to smallest. So just some quick facts about linear versus binary as well. In a linear search, if we have 1,000 numbers, linear search will take about 500 comparisons compared to the binary, which only take about a max of only 10 comparisons, which is, crazy. So let's just jump into some code now. Alright, continuing on with our binary search here. We've got another function prototype of binary search array, our function. And again, this guy's also taking our const unsigned int array, and another 2 of these const ints, right? One for size, one for the value. In my main here, I've created a new array. This guy is another array called binary nums that is in ascending order. So we have 0, 1, 4, 9, 10, 15, 19, 38. So it's from smallest to greatest. Got our function call, passing that in with our size of 8, and we're going to look for the number 15 here. So we're passing in our array as search me. We're going to pass in our 8 as our size here, and the value to find is 15. Let's go ahead and put a couple breakpoints in here, and yeah, let's get started into this guy. So let's get into our function. So we've got search me is our array we passed, and we've got our size and value to find. Remember is 15. So I just got a couple variables here. So we're gonna have a first variable set to 0. Our last variable is gonna be that last element in the array. So we're gonna do size -1, and then just initialize middle to 0. And then our position should actually be -1 here because we want to return -1 if not found. So our base is going to be -1, and it'll return -1 if we go through this whole thing and never find our value. We're also creating another flag here for found to basically set that to true when we found our number. So now we've got another while loop, and again we're going to loop through while we don't find it, and while our first position is greater than or equal to our last position. So we're starting at 0 through 7. So this guy we're going to search through the whole, we're going to start with the whole array bounds, so from first element to last element. Now we're going to find our middle number here, take basically the average, right? Then our middle number is 3, so between 0 and 7 we got about 3. So we're going to check, okay, is the middle index here, middle 3, which has the value of 9. Is 9 the value we're looking for? No, unfortunately not. Okay, well, is 9 greater than or less than 15? Well, not greater than, so it's going to be less than, right? So if it's not greater than, it's going to be our last condition here of the middle element must be less than our special number. So our number, meaning our number, must be in the upper half of the array. So that means we're going to go to the upper half, we're going to change our first array bounds to our middle. And then I believe we got a +1 here, forgot to change that. But we're going to take our first and then take our middle of 3, we're going to add 1 to it, so we're going to now have our first bounds be 4. So we're going to change our bounds here. And now we haven't found it, and now we're looking through 4 through 7, right? We realize it's not 0 through 3, so now we're looking through 4 through 7. Alright, so now we're going to find a new middle, which is going to be 5. Alright, so is our next middle of 5, so is it at 5? Well, we know at index 5 it is 15, and the value we're looking for is 15. So look, we found our value. We're going to set this to true, and then we're going to return our position again, right? So our middle number is 5, going to add 1 to get that kind of number position. And we found it, so we're going to break out of our loop now because that stuff is false. So we've got a position here is 6. So if we go up here to our binary nums, we got 1, 2, 3, 4, 5, and 6, right? So our 6 number is 15. That's the number we're looking for. Again, can think of it as 0 element, 1, 2, 3, 4, or up to 5th element, right? Starting at 6. But it's the 6th number in this array. And that is basically the binary search. So kind of looking at the middle number, getting the middle, and then seeing is it the middle number, or is it greater than, or is it less than the middle number, and changing our bounds from there. Alright, let's move on to our sorts now. Moving on to the bubble sort here. Bubble sort is we're going to be actually sorting. We're actually going to be manipulating data. We're not just searching. We are sorting our data to something, and in this case we're sorting our data to ascending or descending order, so from low to high or high to low. And how the bubble sort works is we're going to start at an element of 0, right? We're also dealing with arrays, vectors here. So starting at our very first element, and we're basically compare that element, the first element, element 0, with the next element in the array, with basically element 1. And we're going to see, well, is the first element, is it greater than element 1? If the 0 is greater than element 1, well, we're going to try to exchange those to sort in ascending order, right? We're going from low to high in ascending order. So we want big number of element 0 to switch with element 1. So we have a bigger number and then take the smaller element and put it in front. And put the bigger element in back, smaller element in front. That's ascending order. And basically we'll repeat this with the rest of them. So we'll check with element 1 and element 2, and then do that same check. Alright, is element 1 greater than element 2? If element 1 is greater, well then go ahead and exchange, put the bigger number in the back and smaller up front. Example 2 is if we start a similar situation, element 0, we're going to compare element 0 with element 1, but this time if element 0 is less than element 1, well, we're only going to exchange them if we want to go for descending order, right, from high to low. So if element 0 is less than, we're going to put our smaller number in the back, and element 1 greater, put the big number up front, right? So it'll be from big to small. And it's the same thing, repeat this with the rest of the elements, elements 1, element 2, if element 1 is less than element 2, blah blah blah. Alright, so going through an example here, we have 7, 2, 3, 8, 9, 1. So we're going to start with our first two numbers here. We have 7 and 2. Alright, we're going to go for ascending order, so we're looking to see if element 0 is greater than. So is the first element greater than 2? Is 7 greater than 2? Yep, it is indeed. So we're going to take our 7 and swap it with our 2 here. So now this is going to be our new thing. We have 2 and 7 swapped, and 2, 7, 3, 8, 9, 1. And so we've done our one swap now. So now we're going to go through the next numbers. So we've done 2. Our next numbers are 7 and 3. Is 7 greater than 3? It is indeed again. So we're going to swap 7 and 3, which we do here. So we have 2, 3, 7. We swap those two with the rest, and we're going to continue to go through. So the next numbers are now 7 and 8. Nope, nothing. 8 and 9, nothing. 9 and 1. Oh, now we've got a number to compare. So 9 is now greater than 1. Go ahead and switch those guys. So we've got 2, 3, 7, 8, and then we swap 1 and 9. And now we're going to go through again. Okay, 7 and 8, again, not again, and 8 and 1. Boom, we found our number to compare. So 8 and 1, going to swap those guys. So we got 2, 3, 7, 1, 8, and 9. Another swap done. Now our next thing to compare is our 7 and 1. And so of course 7 is greater than 1. We're going to switch those two guys. So we got 2, 3, 1, 7, 8, 9. Last thing to do is now do some other comparisons. Is 2 basically greater than 3? No, basically finish it up. We know 1 is going to go up to the front. And basically this will be our ending thing. Right, so I may have skipped this couple steps, but essentially we just go through comparing each of those numbers to each other. So now let's jump into some code. Alright, continuing on with our code here for our bubble sort, we have our bubble sort array. This guy is going to take in just a regular unsigned int array because we're going to be manipulating it. It's not going to be constant. We want to change these values. And then we're going to be passing in the constant size as well. And so I'm calling my function here. We're going to be passing in just this random order here of numbers, and we're going to be sorting that. So we've got numbers and the size of 6. So now here is our function. It's going to go ahead and set up some breakpoints. Let's just kind of get into it. So we're passing in our array here. It's going to be called sort me in here, and we're passing in the size as well. Okay, so this time I'm going to debug, and we're going to look at some memory, because this time now that we're actually sorting, well, we can actually see the numbers in memory change. So we're going to look at the address of numbers here, and this is our array. We have 3, 4, 2, 10, 0, and 8. Those are our numbers. So we've got that in our basically memory here. Those are all our arrays, or all the values in our array. So as we, I forgot to step into here. Okay, so as we go into here, well, now we hop into our bubble sort. And so I've got a couple variables here. We've just got a swap flag, basically another boolean flag, and a temporary integer here. So we're going to go ahead and do this whole thing at least once. So in here we're setting our thing to false as default, our swap as default, and then we're going to go ahead and check. So now we have a for loop here starting with our index of 0, right, and we're going to go through basically the 0 to the size minus 1, and we're going to loop through that. So now we are in our looping starting with index 0 and comparing it to the next index. So is index 0 going to be the same as index plus 1? So we have at index 0, element 1 is 3 greater than 4? And it indeed is not, so we're not going to go ahead and do anything. So we're going to go to the next element. So now we're comparing element 1 to element 2. So element 1 is going to be our 4 here, and is 4 greater than 2? 4 is greater than 2, so we're going to go ahead and go into this if statement here. I'm going to send one of our various values to temp, and then we're going to take the other value here, that second element, put it into the first element here, and as you see we do that. Our first element was 4. We're going to take our 4, put it to 2, and then, we're going to take our 2, put it to 4, take our 4, put it to 2, so that 4 changed to 2, sorry. And then our 2 here should change back to our 4. So our 4 is stored in temp, we're going to change that back to our 4. Boom. So we should see here that our 2 and our 4 are now swapped. And so swap is true. And so while swap is true, well, we're going to continue on with our loop. And we can go ahead and go through the rest. So now we've got a number here. We've got 10 is greater than 0. So now our 10 value here and our 0 value are going to change. So our 10 went to 0 and our 0 here should go to 10. Boom. And those two have swapped. Again, leaving swap true. And we found another two numbers here. So we have 10 is greater than 8. So now we're going to have 10 here and 8. And 8, 10 is going to become 8. It did. Our 8 here is going to become 10. Boom. And again, we've swapped those two guys. And so now we're still true. So we're going to go ahead and continue to loop through. And basically, I'm just going to hit continue here. As we can kind of see, we're just going to be changing some values. So right now we've swapped. So we got 2 in the front, 3 now, 0, and 4. If I continue again, now we've swapped 0 and 3. If I continue again, well, now we've swapped our 0 and 2. So we've got 0, 2, 3, 4, 8, and 10. And so now, pretty much, now that our swap is false, well, we are done. We have completely sorted our numbers. And so we've gone from 3, 4, 2, 10, 0, 8 to 0, 2, 3, 4, 8, and 10. Right, these guys are, remember, memories are stored in hex, so A is equal to 10. So that is our bubble sort array. Basically comparing two adjacent memory locations from an array or vector, right, seeing which one is greater than, and then swapping accordingly. Not too bad, but basically that is our bubble sort. So now let's get into our last thing here of a selection sort. Okay, so hopping into the last part of our thing here, we have the selection sort. For our selection sort, it's going to be another sort, and so we're going to be sorting data in ascending or descending order. And yet again, we're going to start at element 0, the first element. And what we're going to do this time, though, is actually we're going to end up looping through the whole array, and we're going to try and find the smallest value in the array. So we're actually looking for the smallest value in the array. Once we find the smallest value, we're going to go ahead and take the smallest value and replace it with kind of essentially the smallest index. So if we find the very first smallest value, well, we're going to put that in the very first element, right, at element 0. Repeat this with the next smallest value, right, the next smallest value above that, and then replace that with the next smallest index, right? So if we found our second smallest number, well, we're going to put that in the second element. Looking at an example here, we have 5, 7, 2, 8, 9, and 1. So basically, we're going to search through this. Alright, so which one is the biggest? So we're going to have 5. Alright, is 5 the smallest? Let's see, is 5 greater than 7, or is 5 smaller than 7? Yes. Is 5 smaller than 2? No. Alright, so not our smallest number. So we're going to go through 7, we already know. Okay, 2. Is 2 our smallest number? Well, is 2 smaller than 5? Yes. Smaller than 7? Yes. Smaller than 8? Yep. Smaller than 9? Yep. Smaller than 1? Nope. Okay, well, we'll continue searching. Alright, we know 8 is not the smallest. Excuse me. We know 8 is not the smallest. We know 9 is not the smallest. Okay, 1 the smallest. Right, 1 smaller is smaller than 5, smaller than 7, smaller than 2, 8, and 9. 1 is our smallest number. So now we're going to take that 1 and throw that guy up in front. Right, we're going to put that in the first element here. So we've got 1 up in front. Now we're going to look for the second smallest number. We know 1 is our smallest. So again, is 7 our smallest? No. Is 2 our smallest? Well, yeah, we can see 2 is our smallest. We're going to take our 2 and put it in the second element there. Now looking for the third smallest, well, we know 7, 8, 9 are not, so 5 must be our next smallest number, so we're going to put 5 in that third spot. So we've got 1, 2, 5 now in the third spot, and continue on. So 7 is now our smallest, going to put it in the next spot, 7, and then our next smallest number is going to be 8, going to take 8 and put that guy, and then we've got it sorted in ascending order. Very nice. Let's hop into our selection sort code. Alright, finishing up with our selection sort array here, we've got our function, and we're passing in another regular unsigned int array. Going to be manipulating it, going to be changing the value, so not const, and then passing in our const int size as well. And so we've got a function call. We're going to use that same numbers. We're not going to call the other function, so it will stay in a random order, and we're going to sort it using selection sort here. passing in our array and our number of 6 here. Alright, so I'm going down to our function here. We've got our selection sort function right here, passing in our array as select me and our size. So go ahead, put another couple more breakpoints in here, and this guy we're really going to be able to see change. So again, we're going to look at our array here of numbers, right? This is going to be the numbers that's going to be getting sorted. And so let's hop into our function. So we've got a couple variables here. We're going to have a minimum index and a minimum value here that we're going to be using to search and sort our array with. So we've got a loop here starting with our index here of start search at 0, and we're going to be searching from basically 0 to size minus 1 again. And so what we're doing here is now starting our search part. So we're going to set our index to that start search, and we're going to set our minimum value and check to see is our number at the first element, which we happen to have 3, is our number at first element, is that our minimum value. So we're taking this 3 and we're going to be comparing it basically to all these rest of the values. And as 3 becomes the minimum value, well, we're eventually going to find another number that's going to become our minimum value. And so our minimum value is 0, so we have found our minimum value. I know I kind of skipped through that, but basically at index 5 we have found our minimum value of 0. And so we are done with our loop. We have found our absolute minimum value. So at our index here of 4, our minimum value is 0. And then we're going to set that to index 0, right? We want to take the smallest number, put it in the first place. So as you can see in our array here, we have 3, 4, 2, 10, 0, and 8. So as we can see here, we're going to change this. Our 0 became a 3, and then our 3 will become a 0. So we have basically swapped those positions now, swapped those numbers, so our smallest number became our first value. So now I'm just going to go ahead and kind of continue. Basically, it loops through to find the next minimum value and the next index, and we're going to use those two guys. So our next minimum index, or our next minimum value, is at index of 2, and that next value is going to be 2. So and since we're now at that next index, well, our 2 is going to become our second index. So we're going to, wherever our 2 is, that's going to become our 4, and then our 4 is going to become our 2, right? That's index 1, index 2. And basically we can kind of just loop through and continue to see these guys change, right? So now, our 3 became our 4, so now our 4 should become our 3. As we continue on, well, now our 4 is our next smallest, so 4 should swap with our 10 here, right? We want to put it in the next index, so we're going to swap it with our 10, so 10 becomes 4, and where we had our 4 before became 10. Going to the last one, we have 8 and 10 here, which should just go ahead and switch. Our 8 turns into 10, and our 10 turns into our 8. And so now we have completely sorted this algorithm, or use this algorithm to sort our array. So we've got 0, 2, 3, 4, 8, and 10. That is indeed in ascending order. And so we used basically looping through the array to find the smallest value, taking our small value, putting it up in front of the array, and then looking for the next smallest value, and then putting it in the next smallest index or next lowest index, right? So basically starting at index 1, putting a low value, putting the next low value, next low value, next low value, next low value, and the last lowest value. And that is essentially our selection sort array here. So I believe this mostly covers all of our topics for our linear search, our binary search, and our two sorts of bubble sort and selection sort. So I hope you learned something. I hope this maybe was some good review. Thank you guys so much for watching. If you enjoy these videos, make sure to subscribe. I kind of like doing these videos. I hope these help. So thanks again, and I'll see you guys next time.